Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. The number of severe storms that strike city J in a year follows a binomial distribution with n equal to 5 and p equal to 0.6. So it's a sum of 5 independent Bernoulli trials with probability of success of 0.6. Given that m severe storms strike city J in a year, the number of severe storms that strike city K in the same year is m with probability 1/2, m plus 1 with probability 1/3. That with is unnecessary, sorry. So m plus 1 with probability 1/3 and m plus 2 with probability 1/6. Calculate the expected number of severe storms that strike city J in a year during which 5 severe storms strike city K. Just one important observation. 5 severe storms strike city K. That's the second city. And for a number m of severe storms in city J, you can have m plus 1, or m plus 2 in city K. Okay? That's important to remember. So that 5 could be m from the other city, could be m plus 1 from the other city, or could be m plus 2 from the other city. So here's the solution. Let us write J for the number of severe storms that strike city J, and let K be the number of severe storms that strike city K. We are looking for the expected value of J given that K is 5. We also have this, that probability that J is equal to J given that K is equal to 5 is the probability that K is equal to 5 given that J is equal to J, times probability that J is equal to J, divided by probability that K is equal to 5. It's just from the definition of the conditional probability, or it's a form of very simple statement of Bayes' theorem. But very simplistic, really. It's direct consequence of the definition of the conditional probability. Also, what we have is this, that probability that K is 5 given that J is 3 is 1/6. J can't be any less than 3. It has to be 3, 4, or 5, because that 5 is equal to m, or m plus 1, or m plus 2. So what is m if K is 5? Well, it could be 3, 4, or 5. So it's equal to the probability that K is 5 given that J is 3 is 1/6. Probability that J is 3 given the nature of the distribution of J, well, it's a binomial distribution, so it's 5 choose 3 times 0.6 cubed times 0.4 squared, and that's 0.3456. And probability that K is 5 given that J is 4 is 1/3. And probability that J is 4 is 5 choose 4, 0.6 to the 4th times 0.1 to the 1st, and that's 0.2592. Then probability that K is 5 given that J is 5 is 1/2. And probability that J is 5 is 5 choose 5 times 0.6 to the 5th times 0.4 to the 0. And that's 0.07776. And therefore probability that K is 5 is probability that K is 5 given that J is 3 times probability that J is 3, plus probability that K is 5 given that J is 4 times probability that J is 4, plus probability that K is 5 given that J is 5 times probability that J is 5. And it's equal to 1/6 times 0.3456 plus 1/3 times 0.2592 plus 1/2 times 0.077 0.76, and that's 0.18288. Also, probability that j is 3 given that k is 5 is the probability that k is 5 given that j is 3 times probability that j is 3 over the probability that k is 5. We just calculated that probability that k is 5, so we use it here. So this becomes 1/6 times 0.3456 over 0.18288, and that's 0.31496. Probability that j is 4 given that k is 5 is probability that k is 5 given that j is 4 times probability that j is 4 over the probability that k is 5. And that's 1/3 times 0.2592 over 0.18288, and that's 0.47244. And the last value here is calculated, well, the same way, but you could just take 1 minus the other probabilities, but nevertheless, it's probability that k is 5 given that j is 5 times probability that j is 5 over probability that k is 5. That's 1/2 times 0.07776 over 0.18288, and that's 0.21260. And the expected value of j, given that k is 5, that's the quantity we're looking for. Well, it's each of the values, possible values, which are 3, 4, or 5, times its probability, which we just calculated those 3 probabilities. So it's 3 times 0.31496 plus 4 times 0.47244 plus 5 times 0.21260, and that's approximately 3.89764, and that's answer C. Please remember, this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.